All right, so this video is continuation of operations with radical expressions. And this time we're going to look at multiplying with double distribution, also known as FOIL. And then we're also going to look at how to rationalize a denominator. Basically, we don't like radicals in the denominator, so we're going to learn how to get rid of them. Okay. So to use the double distributive property, also known as FOIL, to use the double distributive property, you distribute the first term through the second set of parentheses, then the second term through the second set of parentheses, and then finally you simplify the expression. And you may have heard me say FOIL. So FOIL is also another term for double distribution. Okay, the first, you multiply the first two terms, then you multiply the outside two terms, and then you multiply the inside two terms. I know this is terrible handwriting. And then you multiply the last two terms. That's that FOIL method. Okay, double distribution. Right. Take the first two terms, multiply them. Take the outside two terms, multiply them. Take the inside terms, multiply them. Take the last two terms and multiply them. Also known as double distribution. So let's take a look at an example here. So if I am using FOIL, or I'm using double distribution here, I'm going to take this first term, this 1, and I'm going to distribute it to the root 2, and I'm going to distribute it to the 5 root 3. So 1 times root 2, well, remember, once you're outside of the radical, you don't want to go in. So 1 root 2 is just 1 root 2 or root 2. 1 times 5 root 3, well, 1 times 5 is 5, so we get 5 root 3. Remember, because anything times 1 is itself. Then we're going to take this negative root 3. You got to remember this minus sign. And we're going to distribute it to the root 2. And we're going to distribute it to the 5 root 3. So we have negative root 3 times a positive. Negative and a positive makes it a negative. And they're both under the radical. So we're going to multiply them together. You get root 6. Then we're going to take negative root 3 times a positive 5 root 3. Negative and a positive makes it a negative 5. Root 3 times root 3 is root 9, because 3 times 3 is 9. Now we're going to go through and we're going to simplify. Well, I always like to see, is there any perfect roots? Hey, look, there's a perfect root right here. That's root 9. So we can change the square root of 9 to 3. So really, we have 5 times 3, which is 15. So this is going to change into negative 15. Next, okay, root 6, root 3, root 2, none of those are like terms. None of them can be split, so we're done. All right, so we got 6. So we got root 6 minus 3 root, and we got the 5 plus, and then we got the 2 in the root. So this is our answer. Root 2 plus 5 root 3 minus root 6 minus 15. And next, let's look at this next one here. All right, let's use this cool blue right here, like this blue. All right, 2 root 2 plus 1 times 4 minus 3 root 2. So we're going to take this 2 root 2, and we're going to distribute it to the 4. We're also going to distribute it to the 3 root 2. So 2 root 2 times 4, well, outside and outside gives me 8 root 2. Right? And 2 root 2 times negative 3 root 2, well, 2 times negative 3 is negative 6. Root 2 times root 2 is going to give me root 4. Next, I'm going to take the 1 times the 4, and I'm going to take the 1 times the negative 3 root 2. 1 times 4 is 4. 1 times negative 3 root 2 is just negative 3 root 2. Next, we simplify. As I mentioned, I always like to find, are there any perfect roots? Yes, 4. We can turn 4 into 2. So now we have negative 6 times 2, which is negative 12. We'll include this plus 4. Next, are there any radicals that need to be broken down? Well, no, we have a root 2 and a root 2. Well, those are like terms, but I'm going to rewrite them down here. 8 root 2 minus 3 root 2. And as I mentioned, I want to get a different color here. We have an 8 root 2 and we have a negative 3 root 2. Well, those are the same. 8 minus 3 is 5. So we have 5 root 2. All right. And then if we take a look here also, we have a negative 12 and a positive 4. Those are like terms. Negative 12 plus 4 is going to give us a negative 8. So we have 5 root 2 minus 8. And that's it. That's our final answer here. So when you double distribute, make sure your first term goes to everything in the second term, and then blah, blah, blah. And then the last thing, make sure you simplify. When we simplify, I always like to look to see if there's any perfect roots first. If there's any perfect roots first, I like to get rid of those and get them down to basically an integer. Then I like to see, are there any radicals that can be broken down or simplified? Then I go to the like terms. All right, next, let's look at a couple definitions. Rationalizing the denominator. This is basically a process in which radicals are eliminated from the denominator. We don't like radicals in the denominator. Okay, they don't look good under there. All right, the radicals, to be radical, they don't like to be under. To be radical, they want to be on top. All right. So, and then the other thing that goes with these is what's called conjugates. Conjugates, I think it's a fun word to say. All right, it's when you change the sign, so a positive to a negative or a negative to a positive, between the terms of a binomial. So for example, 3 plus root 2, the conjugate is 3 minus root 2. And you're going to see where this comes into play here in just a little bit. All right. And then lastly, to rationalize the denominator. When the denominator is a monomial, we multiply the radical in the denominator over itself. Okay. So to rationalize it, basically, we multiply by whatever's in the denominator. All right, so let's look at some examples on how to rationalize the denominator or get rid of the radical in the denominator. So really what we're doing is we're technically multiplying by 1. Because if you remember, anything divided by itself is 1. So to get rid of this radical in the denominator, we're going to multiply by root 5 over root 5. Again, we're multiplying by 1 because root 5 divided by root 5 is 1. But we don't like the radical in the denominator, so we have to multiply it. So if we look here, if we use our normal rules, we have 6 times root 5, which is 6 root 5. And then we have root 5 times root 5, which is root 25. And hey, look, 25 is a perfect root. So we have 6 root 5 over 5. And now, the math people are happy. There's no radical in the denominator. And so 6 over root 5 is the same thing as 6 root 5 divided by 5. If you plug that into your calculator, you'll get the same answer. Okay. Next, let's look here. Well, before we start doing multiplying, we can look and see. We can simplify these. 8 over 2. So we can say this is technically 8 divided by 2, which is 4. So technically, we have 4 over root 3. All right. And that means to get rid of that root 3, we're going to multiply by root 3 over root 3. Okay. So then we have 4 root 3, which is 4 root 3, over the square root of 3 times the square root of 3, which is the square root of 9. And the square root of 9 is just 3. So we have 4 root 3 over 3. There we go. Now, if say you couldn't simplify, let's say we had like 7 over 2 root 3. So you can't simplify the 7 and 2. You only need to multiply by root 3. It'll still cancel out the radical. Okay. Because then if you multiply by root 3, you'd get 2 times root 9, which is 2 times 3, which is 6. All right. So if you have something like this and you can't clear the coefficient, just multiply still by the radical right there. All right, let's look at another one. We got 5 root 7 over 3 root 11. Again, we can't clear the coefficients. Right? Radicals aren't the same. We don't like this root 11 in the bottom, so we're going to multiply by root 11. We're going to multiply this by root 11. Right, now we just multiply. 5 root 7 times root 11 is 5 root 77. 3 root 11 times root 11 is 3 root 121. 121, square root of that is 11. So we have 3 times 11, which is 33. So we have 5 root 77 over 33. 5 and 33 can't be simplified. That's our final answer. Next, we have 23 over 2, and they're both under the radical. Well, if you remember the division property, this is technically root 23 over root 2. Oh, man, there's that radical in the denominator again. So let's multiply by root 2 over root 2. Okay. Root 23 times 2 is going to be root 46. And then I'm going to show you guys a little trick. So hopefully you're catching on. So like root 11 times root 11 was root 121, which actually just was 11. So root 2 times root 2, it is root 4. Well, what's the square root of 4? 2. So root 2 times root 2 is just 2. And that's our answer. So anytime you take roots, multiply them together, and they both have the same radicand, it's just the radicand underneath. So root 2 times root 2 is 2. Root 11 times root 11 is 11. Root 3 times root 3 is just 3. And lastly, to rationalize the denominator when the denominator is a binomial, here, there, multiply by the conjugate. This is where that conjugate comes into play. I mixed the A and the G up. Conjugate. This is supposed to be a G, and this is supposed to be an A. Good job. You spelled really well. And let me erase some of this stuff here. There we go. All right, we got it. All right, let's go blue. Blue. Blue, 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 blue. All right, so 3 over 2 plus root 6. Well, we don't like the radical under the denominator, so we need to multiply by the conjugate. So we're going to multiply by 2 minus root 6. And 2 minus root 6 is we're still multiplying by 1 because this is the same thing over itself. I always like to throw these all in parentheses just to remind myself I need to distribute when I do this. All right. So we're going to do 3 times root 2, or 3 times 2 and 3 times root 6, which gives us 6 minus 3 root 6 over 2 plus root 6 times 2 minus root 6. We're going to do this first one out. I'm going to show you. So we have 2 times 2, which is 4. And then we have 2 times negative root 6, which is negative 2 root 6. And then we have root 6 times 2, which is plus 2 root 6. And then we have root 6 times root 6. And if you remember, we talked about this, okay? The same number into the radical, root 6 times root 6 is just 6. Well, positive and negative makes it a negative. Now, take a look here. We have like terms. We have a negative 2 root 6 and a positive 2 root 6. Hey, look, those cancel, leaving you with just 4 minus 6, which is negative 2. So now we have 6 minus 3 root 6 over negative 2. And for now, we're going to leave this here as this answer. I'm gonna come back and talk to this another day. But we can simplify this even more. And we'll talk about this one another day. All right, I just want to get to this part right here. Next, we have root 5 over 4 minus 2 root 7. Well, here our conjugate would be 4. It's a minus, so now it's a plus 2 root 7. And we're going to multiply this by 4 plus 2 root 7. All right, so now we're going to do our distribution. Oh, forgot. Let me put my parentheses in here. Distribute. So 4 times root 5 is 4 root 5. All right, root 5 times 2 root 7 is going to give us plus 2 root 35. all over. Now we need to do this. Well, we have 4 times 4, which is 16. We got negative 2 root 7 times positive 2 root 7, which gives us negative 4 times 7. So then we have 4 root 5 plus 2 root 35. Well, this is 28. 16 minus 28 is negative 12. Where did I get 4 from? Mr. Harris can't do some math. Oh, I know where. 2 times 2. Right there. And again, this can be simplified even more. We'll talk about it later. Last one. Last 2. Root 2 over root 5. We have root 2 over root 5. Oh, here's one of the easy ones. We love these ones. Root 5 over root 5 gives us root 10 over root 5 times root 5 is just 5. Love this one. This was nice and easy compared to my conjugates. All right, and last one. Hey, let's change up some color. Love changing up our color. So we have 3 over 1 plus root 2. Well, here's that conjugate. 1 minus root 2 over 1 minus root 2. Again, I like to throw my parentheses to remind me to distribute. Let's distribute. So we get 3 minus 3 root 2 over 1 times 1 is 1. Root 2 times root 2 is 2. So it's minus 2. So we get 3 minus 3 root 2 over negative 1. Or negative 3 plus 3 root 2. Boom. This is dividing by our